Assalamualaikum and hi everyone. My name is Nur Shakina, and in this video, I will present my full solution for task 1, where we use Lagrange polynomial to approximate stock prices for Tenaga Nasional Berhad. For part A, our project guidelines require us to assume that 1 month is equivalent to exactly 30 days, creating a clean mathematical timeline counting up to day 1 to day 331. However, because the stock market closes on weekends and public holidays, no stock data exists for those days. Looking at all 12 parts of our table from left to right, day 1 shifts to May 2nd because May 1st was closed for the Labor Day public holiday. Day 31 shifts to June 3rd because June 1st and 2nd were closed for a weekend and the King's birthday holiday. Day 61, Day 91, Day 121, and Day 151 stays exactly on July 1st, August 1st, September 1st, and October 1st because they were regular open business days. Day 181 shifts to November 3rd because November 1st and 2nd fell on a weekend. Day 211 stays exactly on December 1st since it was an open Monday. Day 241 shifts to January 2nd because January 1st was closed for the New Year's Day holiday. Day 271 and Day 201 shift to February 2nd and March 2nd because the first of both months fell on a Sunday. And finally, Day 331 lands perfectly on April 1st because it was a regular trading Wednesday. For part B, we use quartet Lagrange interpolating polynomial, which requires 5 data points to solve a 4th degree equation. For part B1, we approximate the price for June 5th, 2025, which maps to day 35. Since it sits near the beginning of our timeline, we select the first 5 table entries, day 1, 31, 61, 91, and 121. By plugging day 35 into our formula to calculate the Lagrange coefficients and multiplying them by the corresponding stock prices, we sum the products to get a final estimated price of Ringgit Malaysia 14.18671. For part B2, we estimate the price for March 11, 2026, which corresponds to day 311. Since day 311 sits at the very end of our dataset, using early data points would cause severe errors. So we shift our data window to focus entirely on the final 5 table entries, day 211, 241, 271, 301, and 331. Like in part B1, running the same Lagrange polynomial calculations across this local data window yields our final estimated closing price of Ringgit Malaysia 14.26554. Finally, for part C, we compare our polynomial predictions against the true historical closing prices from the market website to evaluate accuracy. For June 5th, 2025, the true price was Ringgit Malaysia 14.20000, giving our estimate a tiny absolute error of just 0.01329 and a relative error of just 0.09359%. For March 11, 2026, the true price was Ringgit Malaysia 14.24000, resulting in an absolute error of 0.02554 and a relative error of only 0.17935%. In conclusion, both approximations are highly accurate, but June 5th is more precise because it sits safely inside a stable, well-supported internal cluster of data nodes, while March 11 exhibits a slightly higher error due to boundary volatility, as high-degree polynomials naturally tend to bend and oscillate near the outer edges of a dataset.
Assalamualaikum, my name is Nur Nadira. So today I will explain to you guys solution for case study 2, which the title Newton divided difference and least square approximation. So here the data we got Malayan Banking, which the blue line, and CIMB group, the red line. So the duration for this data is 1 year, May 25 until April 26. So looking at our first question is to extract information from the graph monthly basis and then construct Newton finite divided difference up until 5th order for both company. So here I make the table. X we got 12 month and Fx we extract the data from the graph, and the order value I got by using this formula in black box. Same goes to CIMB Bank. We got 12 months and this data extract from the graph, and the order value I got from using this formula in black box. So after that, completing our first question, Then second question is to calculate Newton forward polynomial, which the x0 equal to 1 for Malayan banking. So how's the solution? So x0 equal to 1. So we need to do this formula syntax. So it will be like this. And the data we need to use from up here until down here. So after that, we need to substitute the x0 equal to 1. So the answer will be 0. So how to prove it? The answer is correct. Refer to your table. X equal to 1. We got 0. So it matches your table. So and then this third question is to calculate Newton backward. And x dot equal to 11 for CIMB group. So how's the solution? So here is the formal syntax we need to use, which is, if you notice, x1, negative x, negative 1, and the data we need to refer from down here to up here. So your answer will be 0.17. So how to know your answer is correct? Refer to your table. X equal to 11 and your fx equal to 0.17. So it matches your table. And then B, refer to the same data but using different method, which discrete least square polynomial of degree 2. So how's the solution? So we know that degree 2 m equal to 2 and it shows linear equation. So Lion Bank, this is sum up value for x, fx, x square, x cube, x power 4, xy and x square y. So we use this value into this matrix 3 by 3 to find A0, A1 and A2, and then substitute this value into this linear equation, and we got this answer. Same goes to CIMB Bank. We use matrix 3 by 3 and using sum up value from the table or using your calculator to find A0, A1 and A2. So after get your these three value, substitute your answer into this equation, and your final answer will be like this. That's it for case study 2. Thank you.
Assalamualaikum. My name is Nazratul Husna, and in this video I will present my solution for task 3, least first approximation. In question A, it says to determine the value of A and B using the discrete linear least first approximation. First of all, use this equation and then solve them to get them in a linear form. In a linear form, like this. And then label the new value for y, A0, A1, and also x. Then construct the table, fill in the value for x and y as in table 2. Then find the new x and new y by using the value in x and y here. Substitute them into the equation of new x and new y, and you will get this answer for new x and new y. Then use the value of new x and new y, calculate them to find the total of x, x square, y, and also xy. Then use this data, substitute them into this equation, and you will get the final answer for A0 and A1. Then use this equation to find value for B, substitute the value of A0, solve it, and you will get the answer for B. Same goes for A. Use this equation and then substitute the value of A1 and B, and you solve it, you will get the answer for A. Then use this equation, substitute the value A and B that you just solved, and this will be the final answer for question A. For question B, it says to approximate y 3.35. Use the equation that you have solved in A, this, and substitute the value of x, which is 3.35. Solve this equation and you will get this answer which is 1.0854.
Hello, my name is Siti Hanani. I will continue to the task 4. So for the first question, state the general equation, the general polynomial of degree 2. Degree 2, we know that m equal to 2. So for the functions, a0, p0x, p0x equal to 1, and a1, p1x, p1x equal to x, and a2, p2x, p2x equal to 1 over 2, 3x squared minus 1. So for the question 2, identify if any suitable linear transformation if necessary. So for negative 1 and 1, no transformation needed because the original interval is already in the standard interval, negative 1, 1. So for the 0, 2, linear transformation. So we need to change that 0, 2 to the negative 1 and 1 by using this formula with a equal to 0 and b equal to 2, and we substitute the value and we will get the t equal to x minus 1 and p plus 1 along with the x equal to dt. So for the question 3, find the polynomial on the interval. So for the first, negative 1 and 1. So m equal to 2, same as the above question. Just state back. So for the coefficient, we want to find the a0, 1, a1 and a2. So this is a equation that we need to remember. So when k equal to 0, we just substitute into this formula. So we will get the value, and when we get the value, we just substitute to the functions. When this, we need to multiply with every in the bracket and until we get the fx, the final answer. So move on. So we continue to next question, b02. So this we just follow by the previous equation, just follow back. So for the next step, we should use x equal to a plus b t. So subs x equal to 0 and 2, and we will get equation 1 and equation 2. So for both equation, we get into the metric form and we will get a b1 1. So for the next step, we just substitute back the value that we'll get. So for the x, we will get 1 plus t, and t will get x minus 1. So for the next step, we need change x equal to t. So this is the original equation functions. Then this is the new function that we substitute back x equal to this one. So for the coefficient, we want to find the a0, a1 and a2. So we just use the general equations, and this is the t because we already changed, and substitute all and we will get the answer. So for the last step, we just substitute back into the equation. So this is a1 and a2, a0, a1 and a2. So we should multiply with every to get the answer, final answer for ft. So after that, we need to change back xt, t equal to x and t equal to x minus 1. So that for fx functions. So fx function is for our final answer. So we substitute all and we get this final answer.